everyone. Welcome to physics. Our goal here is not just to learn facts, but to really understand the how and why of how they work. So let's get started. Today our topic is significant figures. No, not significant figures as in Albert Einstein, but in mathematical calculations. There are a lot of different rules for figuring out whether a number is going to be significant or not when you've got a number displayed. I like to pick something that's simple to use because it's something I can easily remember. And so I like the Atlantic-Pacific rule for significant digits. All of us can picture a map of the United States. The Atlantic Ocean is on the right and the Pacific Ocean is on the left. So let's take a look at how we can develop a rule from that. On the Atlantic side, this is the rule you use when the decimal point is absent. So A for Atlantic and absent. The rule is you start on the right side of the number at the first non-zero digit and count all the way to the Pacific side. So let's take a look at some examples. If I look at the first number that I have here, there's no decimal, so I start on the right at the first non-zero digit, which is this 5, and then I count all the way over to the left of the number. That would be 5 significant digits. Well, that one's pretty easy because there weren't sort of tricky zeros at the end or the beginning. Let's take a look at the second number. Now this one does have a 0 present on the end, but still the decimal point is absent. So I would start at the 6, the first non-zero number, and all the way to the end. That would give me 1, 2, 3, 4, 5, 6 significant digits. And now for the last number in my group, 100. There's no decimal point. I start at the first non-zero digit, which is this 1, all the way to the end. That's only one significant digit. Okay, let's look at the Pacific side. On the Pacific side, the decimal point is present, so Pacific for P and present. You start on the left of the number at the first non-zero digit and count all the way to the Atlantic side. If we start with our first number, I start on my Pacific side, the left side of the number, all the way to the end. That would be 503.45 or 5 significant digits. The second number, I still start on the Pacific side, 503.450, and I do count that last 0. You start at the first non-zero digit, which is my 5 here, all the way to the end, even if it includes zeros. Now, last number in the group here, I've got this number that starts with a couple of leading zeros. I don't count those. I start at my first non-zero digit, which is 5, and go all the way to the end, including any zeros. So this number would have 6 significant digits in it. Let's take a look at why significant figures matter. We can learn all the rules in the world, but if it doesn't, what good is it to know this? Well, let me give you a simple example that was really costly. In 1999, a Mars rover crashed once it got into near the Martian atmosphere. Before it could get to the surface, it misfired and crashed into the surface. Guess how much that cost? $125 million. When they figured out what the problem was, it was really just a simple error. The engineers had failed to make the conversion between English units and metric units. Ouch! That's a $125 million ouch. Now that's not exactly what we're talking about with significant digits, but it's an example of a simple math error where the actual numbers matter, and digits in a number matter when you're doing scientific calculations. Okay, so we're not all sending Mars rovers up. What about you close to home? When you enter your answer into the answer key on the online homework set, it's going to take a look at what the answer should be and how close did the answer that you typed in come to that. So I pasted in an example here. In orange, this is what the answer is supposed to be to this question. And you can see the student has it marked wrong. You'll see an X over here if it's marked incorrect. Now the correct answer was -272, and she typed in 272.14. So it marked it wrong for a couple of reasons. Number one, she typed in a positive number, should have been negative. But in terms of significant digits, she's got 5 significant digits when the answer key is only looking for 3. And you might ask yourself, well, how do I know how many digits to include? You take it from the data in the problem itself. If I look up at the problem statement, I've got this number, 13,500. The decimal point is absent. How many significant digits are there in that number then? That would be 3. My second piece of data is this negative 15.5. Decimal points present, I count all the digits, that would also be 3. And then a third number in this data is 525. Again, 3 significant digits. Your data in the problem will be consistent, and you need to enter your answer in terms of the number of significant digits that the problem presents. So just a closer to home example of why it's important. Okay, if we know how to identify significant digits, now we need to be able to do it when we do mathematical operations. So let's look quickly at the 2 rules you'll need. For adding and subtracting, you can only have as many places past the decimal as the number with the lowest number of decimal places. So if I add these 2 numbers together, 23.42 added to 1.38972, add them up and I get 24.80972. Well, my rule says I can only have as many places past the decimal as the number with the lowest number of decimal places. So that would be this number right here that only has 2 places past the decimal. So I would need to round this to 24.81. Okay? Your turn. What I want you to do is add 4.67 and 13.9653. You can pause the video. I'll wait just a second, let you do the computation, and then I'll tell you what the answer is. To it, the answer to that last one was 18.64. Hopefully that's what you got. Multiplying and dividing. Your final answer can only have as many significant digits as your number in your data with the least significant digits. So here I'm multiplying 2 numbers together, 345.67 and 20. 20, of course, has only 1 significant digit. So if I look at my first number, actually that would be this one, that has 5 significant digits. So if I was writing this in, we'll fill in the blanks here. Let's fill them in. So that first number has 5 significant digits. 20 only has 1 significant digit, so I have to round my answer to the number with the least significant digits, and so I've got to round it to 1 significant digit. So if this is what I get when I plug in the numbers on the calculator, 6,913.4, I need to round that to only 1 significant digit. So I look at my rounding rules, 6913.4 is closest to 7,000 than 6,000, so my answer is going to be 7,000 is the answer I would get for that. And I write it, of course, without a decimal point absent, only of 1 significant digit in that answer. Okay, your turn. Divide 28.76 by 33. Give you a second to come up with the answer. And I would round my final answer to 0.87. All right, that's it. Thanks for watching.